Now, let's talk about normal distribution. Most of you, if you've spent any time, reading education or listening to things that occur in education, you talk about what is a normal distribution, and that's basically this normal curve. And that is how, if we have a set of scores and we have enough of them, theoretically they should have a normal distribution. So you have a few at the lower end, a few at the upper end. Right in the middle, you have most of the scores occurring, and that's what an average is. And the most common example of this is IQ scores. The average IQ score is 100. Most people have that, and they're right here. People that are really, really smart, well, there's not near as many of those, so we have less of them, and their scores are up here. People that aren't quite as smart, we don't have quite as few of those either, so their scores are down here. Now, one of the things that will happen when you get a set of data is sometimes your distribution won't be normal, and it will throw off what is called a standard deviation. In other words, you can't calculate a standard deviation anymore because you have to have a mean and a normal distribution. So what happens, or what causes this, is if you have a few very, very high scores, that pulls up the mean. You still have a median, which is back down here, but your mean is starting to move, and this is called a positive skew. If you have a few very low scores, they tend to pull the mean down like this. So now the mean is down here and the median is up here. And any time that this occurs, the mean will always get pulled away from the median. Whether it's a positive or negative skew, the mean is pulling them away from the median. And therefore, if you ever come across a situation where you have a mean score and a median score, and the mean is higher or lower than the median becomes a better representation of the entire sample or the entire population. This tends to happen a lot in salaries. I'm going to use salaries in higher education, for example. There is a few people that make a lot of money in higher education, and when we talk about the average scores of faculty members, if they say mean, that makes it look different than if they say median. So it's very important when you look at data to really understand which type of measure of central tendency they're talking about, because sometimes those two numbers are very different, but one, the median, represents the entire population better than the other, the mean. So that's one of the things that can happen with this. The other thing that can happen is something called kurtosis. If we have our normal distribution like this, that's called a mesokurtic curve. One of the things that can occur is if things are not normal anymore, if for some reason our data has changed, in a normal distribution there's as many people below the mean as there is above. However, if we get more people than we're supposed to centered around the mean, this is the mean right here, that's called a leptokurtic curve. The other thing that can happen is if we have as many, let's take IQ scores. Our average IQ score is 100. And we don't have everybody's IQ scores. So we have 100 people that have 100 IQ. We have 100 people who have 110 IQ. We have 100 people who have 120 IQ. We have 90 people that have, 100 people that have a 90 IQ. 100 people that have an 80 IQ. Well, now this thing is flattened out, and that's called a plateaukurtic curve. And it's not necessarily important that you remember these words. Obviously, we're not going to have a test, and you have to memorize what a leptokurtic curve is. The purpose of this is to understand what happens to data. and sometimes things don't look like a normal distribution. And what is important about not having a normal distribution, if that really throws off your ability to do anything else with statistics, because most statistical tests are based on the assumption of a normal distribution. As I said, any set of scores with mean should also have what's called a standard deviation. The standard deviation is calculated from the scores themselves and the mean. So to better understand this, you have a document called the normal curve, and it looks something like this. I'm going to blow this up a little bit so that you can see what I'm talking about. And this is the same thing. This is a normal distribution, and you have a mean score, which is the score right in the middle. So we're going to take IQ scores as just an example. The average IQ score, the mean score is 100. One standard deviation above that means there's one set of scores above that. So the standard deviation for IQ is 15. So one standard deviation above the mean for IQ scores would be 115. Two standard deviations above the mean for IQ scores would be 130. One standard deviation below would be 85. And two standard deviations below would be 70. Now, the other thing I want you to look at on this, now that's not going to work, is these percentages. 50% of the people, from 0 to 50% of the people, have IQ scores from 100 to 0. 50% of them are above the mean. One standard deviation above the mean means there is 34% of the people above the mean of 100 who have a score between 100 and 115. 34% of them have scores that are one standard deviation below the mean. So another way to look at this is to say there is 68% of the people who have scores between one standard deviation below the mean and one standard deviation above. In other words, 68% of the people in the United States have IQ scores between 85 and 115. Now, as you move your way up, there is a smaller and smaller percentage of people who have those scores. So, for example, two standard deviations above, you take this, which is at 50%, you add the 34% to that, so that's 84%. You add about 13% to that, so now we're at 97%. Only 97%, or excuse me, 97% of the scores, IQ scores, are below two standard deviations. Another way to look at this, there's another number called a percentile rank. And that's another way to look at this, is if you score in the 97th percentile, that means that you scored at or above everybody else on this scale. So as you work your way up, you can see how much less and less common it is to score in these areas. Another way to look at this is only 3% of the people have scores above two standard deviations. Now, the next thing I want you to do when we're done with this video is you have the other thing I want you to look at is standard deviations give you an idea of how scores are distributed around the mean. If it's small, the numbers are very tight around the mean. If it's large, the numbers are very spread out. Every set of scores that has a mean and standard deviation you can have the ability to calculate this. And we're going to look at some examples in just a minute. You have a document called standard deviation. What I want you to do, and it looks like this, is I'm going to have in the chat room, I want you to discuss what the answers to these questions are. I'm going to put a few people in Group A, a few people in Group B, and a few people in Group C. I want you to look at two things. I want you to look at this set of scores and calculate the standard deviation, the 50th percentile, and all these other numbers using this normal distribution table.